Next is air reliefs. Interestingly enough, you can actually collapse pipe when you void all of the liquid in it and start to pull a vacuum on the system, if there's not some place for air to come back into the system. Example, running a main line straight up a hill. If we're running straight up a hill with a main line and we shut that main line off, or for some reason a pipe breaks and all the water starts coming back down out of that main line, you know, ideally what we do is we put a check valve on a main line that's going uphill so the water can't come back at us. We put a check valve down here at the bottom. But what if it breaks in front of the check valve, or somebody leaves a valve open downstream from the check valve? The whole line's going to drain. Well, if there's no way to get air into this line up here, we have to put air in up here. If there's no air coming in, it's going to create a vacuum, and it will suck all of the liquid out of there, including the air. Well, there isn't any air. There's nothing. What you're doing is creating a void of nothing, and it effectively sucks itself flat. And that will destroy, it will just shatter that pipe. And it doesn't matter, if it's plastic, it'll shatter it. If it's steel, it'll just suck it flat. And you get yourself a little kind of a pancake looking thing when you're done. Even big diameter pipe, I've seen pipe 4-foot diameter get ovated till it's about this high and about this wide. It looks like a big oval. Where that happened out on one of the big farms up here on the Columbia River. What we have to do is we have to allow air to come in at the highest point. So we put an air relief at the highest point. And all that air relief has to be is just some kind of a little device that when the water hits it, it closes, and when the water releases, it pops open. Now, air reliefs have a sample of an air relief, and it's basically a ball, a float, that air isn't heavy enough to push up, but as soon as water hits, it pushes it up and seals off a hole at the top of the unit. So this would be standing upright. You can hear the float in there. And it's made out of a hollow plastic, and it's kind of like a ping pong ball filling a hole at the top. So every time that this thing pressurizes, with water, air just lets the ball kind of float in the stream, and all the air escapes around it. But as soon as the water hits it, the water's heavy enough to push the float and make it seat all the way up into the top and seals off. As soon as a bubble of air comes along, the air's light enough to let the ball drop out of place ever so slightly, let that air burp out, and then the water comes back up behind it and seats it up again. So whenever there's water on the bottom, it's up. Whenever there's air on the bottom, it drops off the seat and allows the air to pass out. And see, they got a little deflector on it, because every now and then when the water does hit, you get a little splash of water come out of it. So you can channel that away from yourself. But that's basically what an air relief does, and what it does is it eliminates the possibility of having the line, number one, collapse if you pull a vacuum. Number two, it evacuates the air out of the line so that it can run full of water, instead of having air trapped in the line where there might be high spots in the line where the air will collect. What happens with a pipe is this. If you have a pipeline comes up on a high spot and back down, where's all the air going to go? It's going to collect. All water, all irrigation water has air entrained in it. And the more rapid the water comes into the system, the more turbulence there is, the more air potential there is in the water at the pump site. So if you're pumping out of a stream that's a flowing stream, there's going to be quite a bit of air in that water. Well, unless you had really stagnant water, you're going to have a lot of air in that water. So there could be 10% air in this water. Well, as it comes up, that air starts to separate, and the air is going to run along the top of the pipe. There are going to be little tiny bubbles of air separating out as it runs down this pipe. Well, every time it hits a high spot, they're going to collect, and they're not going to go anywhere. So we got water coming down the pipe, we got air in the water. When it's this high spot, it starts collecting up here. And all those little drops just keep collecting and collecting and collecting and see what's happening? We're diminishing the diameter of the pipe. We're creating an air trap. Well, what we do is simply then plumb in an air relief right here. Put ourselves a little air relief in the system at all the high points, and by golly, that air just exits right out and we eliminate it from the system. And now the pipe can run full of water, and all the air is skimming off the top of the pipe out through the air relief. So that's the procedure that occurs in a pipeline. Pretty valuable thing to have.